All right, so that was a great panel that you just saw from the Dimitri and the other Microsoft partners. Uh, I now have a co-host with me, and Nigama, welcome to Global AI Student Conference.
Thank you so much. That was a great session on uh, personal development and machine learning and how to learn for beginners. So in our next session, we're going to have a session about recommendation systems and different types that are used in our daily lives. Our next speaker is Kaushik, and he's a final year undergrad student, and he's also a Microsoft student ambassador. So let's welcome Kaushik.
Yeah, hi. Uh,
Hi, how are you?
yeah, I'm
Hi,
fine.
Kaushik.
Yeah, so the stage is all yours.
Right,
You can
absolutely.
take it.
Let me know whether my screen is visible or not.
Not yet.
Yeah, I think it's.
Yes.
So, so hi everyone. Like I'll be speaking about recommendation systems and their types in our daily lives and all the different applications that we have. So, like speaking of myself, like I'm also a Microsoft Run student ambassador. I'm currently doing my undergrad final year at PVRIT. So which is in India. So like I'm also a research intern at Carnegie Mellon University, Thailand before. So I'm currently working as a machine learning engineer at Omdana. So I'm really passionate about machine learning, deep learning, data science, and all the different applications. So especially recommendation systems, natural language processing, etc. So like let's get started with this. So like for today, we'll be speaking about the introduction to recommendation systems. We'll be like diving deep into real-time applications that we have, and also like we'll also like work on like checking out different types of recommendation systems, and also like we'll be checking out the Microsoft Azure services for recommendation systems, and also I'll be linking all the resources that are being used so that you can try out like afterwards, like you can go and research more and like more regarding the other topics if you really want. So like coming to the introduction part, like recommendation systems are like general data science application. Like data science is all about providing insights, but coming to recommendation systems, it is all about providing recommendations to the user or to the customer or to any different organization. So like recommendation system itself is present in like each and every field, like coming from healthcare, finance, e-commerce, etc. Like each and every field is using recommendation systems. So like one thing, first of all, let's understand what is a recommendation. So for example, like if I want to go to a pizza place near my home, so my friend suggests that like there is a new place which has been opened. So that like which the pizzas are really tasty and also which is really affordable. So then like this is some kind of indirect recommendation that my friend is giving. So this is something up to me whether to take it or not. So this is something like one-to-one interaction that is going on. So this is some basic thing like where it will go on till the Netflix applications, which is like Netflix recommendation systems, and also like which is the main thing, which is Google search. So when we type a word, we'll get the entire words in the sentence. Like there's a lot like much better like percentage that the words we are typing is the right one. So coming to the real-time application part, so nowadays like recommendations are everywhere. So like for example, when we choose like entertainment zone, so some of the like movies and TV shows that we actually get up as on Netflix and Amazon. So like there are multiple algorithms which are actually used in Netflix. For example, when we first subscribe to Netflix, and then like it will ask you to choose a genre, which is like whether it may be action or whether it may be a comedy or any other thing. So like for example, if I choose action, I'll get all like for one section which is like only related to action movies or action shows, etc. So these are like actually sorted based on the popularity. Like when you choose a movie, there it will tell you the popularity index. So this is something which Netflix, Amazon Prime, etc. does, which is based on the entertainment, like entertainment things. So like and also like LinkedIn uses recommendation systems. when we actually use LinkedIn, we have different types of connections, like first degree connection, second degree, or third degree. So this is the people who are very close, and also which are segregated into different levels. So like the other applications are based on location, like food delivery apps. For example, I want to actually book some order, etc. from my application. Like it will actually show all the all the located ones which are nearby. So which is like recommendations. So we can choose it or not. Like it is up to us. So then like Amazon, Flipkart, and all the other e-commerce websites uses recommendations very hugely. I mean, for example, when we choose Amazon or Flipkart, like we get the running list of top selling products or like each and everything from that. So we can choose something which is whether like people are choosing more on that, which is the top selling products that are represented like on the top shelves, etc. So the other real-time applications that we have is which is used to determine the destinations for the users, which is done by Airbnb. So Airbnb is a very famous company outside India. Like they're what this is basically does is like it will recommend, or it will give you some recommendations which are providing some real-time destinations which you can choose from. Like there are multiple filters that are available there, so you can choose many different locations based on, and also your kind of and also income based things, etc. So the next thing is for example, when we choose a product on Amazon, it will ask you from which retailer you want to purchase from. So there are multiple of retailers below, so it will recommend you to choose from any one, but it will by default it will choose you one, but you can choose anything from that. And also, like coming to other applications like music-based applications, we have Spotify. So Spotify is like, for example, if you like one type of genre, it will actually give out the recommendations based on other view patterns of other people, which will make a more and more personalized based on other users. So like on the below side, you can see the first one is like based from Amazon. So it will tell you more people have chosen the products from the below 4 cameras. So this is like one-to-one recommendation for yours. And then the next screen. So the next screenshot is based on which is LinkedIn. So it is actually suggesting some of the well-known newsletters so that we can subscribe them, etc. So these are some of the real-time applications which are used. And coming to the base case, which is base cases or business case for recommendations. So because recommendations itself is a very big deal, because if a company does not give out good recommendations, it's going to lose out a lot of revenue, and also they can certainly go into debt also. So there are many things to assume before building a recommendation system. So some of the cases that have to be taken care of is the first one is relevance. So the relevance itself is how relevant are the recommendations to the users, whether they are getting the right recommendations or different recommendations. So based on that, it is really important for this for the organization to choose from. Then comes the novelty effect. The novelty is something to attract the users based on different different offers, etc. on an application or an e-commerce website or etc. So then comes the serendipity part, which is serendipity is nothing but surprised or happy. So for example, once a user is searching for an object or for a product for a long period of time, and for example, he he has recommended that product which is he will be kind of surprised to see that which is a great recommendation. So the next one to consider is the increased diversity part. So increased diversity part in a sense, for example, if you want to purchase a mobile phone, so you can select a filter from maybe select from 10,000 rupees to 1 lakh. So it should provide all the mobile phones from that range, which is from 10,000 to 1 lakh. So it should not only showcase the top which is 1 lakh products or the 10,000 products. It should kind of have the frequency, it should display each and every set, which is from 10,000 to 20,000, etc. Till 1 lakh. So this is these are the 4 factors which are really important when it comes to recommendations. When we are actually building recommendation systems, the most important thing that comes up is the data understanding part, because for data understanding, like we require a lot of time, first of all, to understand what the data is offering us, and also how we can create a recommendation system from that. So like before building any recommendation system, like these are the two things that we have to consider, which is like understanding the data characteristics and also data cleaning. So like when you work with machine learning or deep learning or data science, you will know that like most of the work, which is like 60%, just depends on data cleaning. So like this is also very important when it comes to recommendation systems. Like for example, like I want to actually show like how like for one use case where we build the like user item matrix, which is for recommendation systems. So here to build a recommendation system, like we have a movies data set. So where we have the movie ID, where we have the movie, and also the genre. So like here, for example, like when we want the like date, which is for like the first movie, which is the ID. So we like we want the date, which is 1894, in a separate column, so that we can sort it out like based on different metrics that like we like based on different algorithms and the use case. And also like coming to the general, we can actually identify that it is not like sorted properly. I mean, there is a slash between documentary and short where it has to be separate. And also we have some NaN values, which is like in the movie ID 25, we have the NaN value. So we don't want the NaN values, etc. So like this is some code that I'll be presenting now, which is like the first snippet, which is on the top left corner, is based on like whether there is a kind of a date like which is present with the column or not. So like we will be using some slicing operator. So based on the slicing operator, we'll check whether there is a date or not. So if there is no date, we'll be just simply using NaN. Otherwise, we'll be providing another column, which is from like we'll be creating other columns like 1800s, 1900s, and 2000s. So this is like an alternative method to use like based on one-hot encoding. So like one-hot encoding is like just a function that you can use, but this is like more like default manner that you can use. And the last snippet that I'll be using here to actually like do the data cleaning part is like for each and every genre, you will be like you will be placing them into separate columns. And like inside that column, if the movie ID has that genre, it will represent 1. Otherwise, it will be 0. So this is the kind of output that you can get after doing the above two functions. So like based on the genre, we can see that for the first movie ID, we have genre as documentary and short. So here, for the column documentary and unswim row, we can see that the value is 1. And for all the other things, it's 0. And also, like the date is 1894, so it comes under 1800. So it was mentioned as 1. So this is a kind of alternative that you can use for one-hot encoding. That is some like technique which is present in machine learning. So like coming to the different types of algorithms that we have in recommendation systems. The first one is the rank-based recommendation system. So this is like generally the most used recommendation system that is like most popular in sites like Amazon or Netflix or like all the other things where we will get the popular items, for example, like popular books or popular shows or like famous items, etc. So like this is actually based on the sorting mechanism which is done. So like sorting mechanism can be done in ascending or descending order, which is based on completely the use case and also the different kind of like things that we'll be dealing with in that project. So like, and also one more thing that we can actually say with this rank-based recommendation system is that this is not personalized to the user because like this is related to the whole general population. Like whole general population in a sense, like it will it will kind of infer from the entire population and it will give out the results. But like we may like it or dislike it, like it is up to us. But like this doesn't seem to be personalized to many different users. So like for this kind of alternatives, we have different algorithms like knowledge-based recommendation system. So for this knowledge-based recommendation system, so this is kind of a recommendation system which is actually based on a rank-based recommendation system, but like there is a small extension which is added to the like before base system, which is like the filter. So like so the filter in a sense like on the right side you can see that like you can actually choose number of baths and also the square feet and also the lot size, year belt, or like home type, like days on Zillow or keywords, etc., and then click on apply. So this is something like more personalized to the given user or the customer, so that like he can have a choice to choose from, and this is like a small extension. And also like he or she can get more freedom to choose from, like other than the whole general population results that the rank-based recommendation system is like giving out. And also like there is one alternative to rank-based recommendation system. Like instead of sorting etc., we can also use the weighted average. So based on the weighted average technique, we can also get the like recommendations by sorting their like weighted average thing. So like coming to the other recommendation system, which is very personalized and which is kind of like used in all the different applications, which is called as collaborative filtering. So like for this collaborative filtering, like it is based on like it will give out recommendations, which is completely based on other users, which is like other users in a sense we'll have some transactional data or the historical data. So from that we'll be inferring inferring from our choices and also from other data, and based on that it will be giving out recommendations. So like here, like we can have different kind of filtering, which is like item to item filtering, or item to user filtering, or user to user filtering. So it totally depends on the use case, and also it totally depends on the application that we are using in the project. So like on the right hand side, you can see that we have three different users: user one, user two, and user three. So they are choosing like different like different things like oranges, like we have banana, apple, and strawberry, which are different fruits. So for example, when user one is picking orange, apple, and banana, and user two is picking orange and apple, and user three is purchasing, which is the apple. So like if you like if user three wants more and more recommendations, so then what it can say, like info from that is like user one is also liking banana, which is apple, and also it is also liking orange, and the user two is also liking apple, which is chosen by user three, and like user two is also liking orange. So based on that like understanding, orange is also recommended to user three. So this is like based on like not the like general population, but it is like individual population. Based on that we will get the insights and we'll get the recommendations based on that. So for like, and also one more example that I want to like mention here is that, like for example, when let's say John watched Titanic, Avengers, and Avatar, I think like everyone knows this kind of films. So like if Lily saw Titanic and Avatar, it may like also recommend Avengers to Lily based on John's view patterns, because like there is some kind of similar movies which are present in both the view patterns. So this is like like collaborative filtering approach, which is present in all the different applications that we are using currently. So like another example that I want to mention here is like we have four different users, and we have the main user that like he wants to get the recommendations from. So like for example here like let's say like he has already seen some movies, so that is crossed out like already. So based on that, we only have some movies. But after like afterwards, like we don't want to recommend each and every movie to that user, but we want to filter out like us, like some person may give like 5 out of 10 ratings, some person may give 9 out of 10 ratings. So we don't want to recommend like ratings which are below 5 or 6, and like we only want to recommend movies which are like created more by the different users and which has similar taste, etc., based on different genres, etc. So like based on that, like the user will be getting recommendations which are filtered, like more personalized, and also like there is a greater probability or the greater chance so that the user may like that. So coming to the other recommendation systems, which is the content-based recommendation system. So like previously we have discussed about collaborative-based filtering. So in that collaborative-based filtering, like we need to have transactional data, which is the historical data. Like otherwise we cannot infer from that, or we can do different operations like a nearest neighbor, similarity metrics. So that is really necessary. But coming to the content-based recommendation systems, we don't need the historical data. We only need the characteristics of the data. So like before it was based on behaviors, but this is based on characteristics. So for example, like when I want to purchase a bicycle from Amazon, so it will actually like tell me all the like other recommendations like helmet, or like all the other things which are related to bicycle, where other users may also purchase, or like it is related to bicycle, like it is something where like it is like it has some similar characteristics with all the other objects. So like coming to the genre, left, for example, if I choose Iron Man, it will recommend me like all the other action movies, because Iron Man comes under action and also like other genres. So like based on that, it will give out the genres that are based on that genre itself. So like here we don't need the like user item connections like that we like before that we like need for the collaborative based filtering. So like more things you can explore is that like there are many different algorithms. So some of the other algorithms that you can choose from is a weighted average algorithm. Then we have the SVD algorithm, which is very famous, which is singular value decomposition algorithm. And then we have the Funk SVD algorithm, which is kind of extension to the SVD algorithm. And then we also have different techniques that can be based in deep learning and machine learning techniques. So like coming to the SVD algorithm, this is so this includes matrix factorization, and also like this algorithm doesn't work with null values, so you have to clear out you have to clear all the null values, and then you have to use this algorithm. So but coming to the Funk SVD algorithm, this is you can have null values in that. So it is just based on the latent features that you have. So based on that, it will actually get the recommendations and it will provide the recommendations. So that is all about Funk SVD algorithm. And like if you're really interested about like Funk SVD algorithm and collaborative filtering, so these are all the projects like that I did. So I'll be actually like listing out at the end so that you can actually like go there and practice afterwards. So like coming to the like Microsoft Azure services for recommendation systems. So we do have a lot of different Azure services, but I'll be speaking about our products recommendation service or the solution. So so this is actually tailored towards e-commerce or based on like e-commerce based solutions or problem statements. So this is for e-commerce. Product recommendation is the most important feature. Like almost all the e-commerce are using this because by providing better recommendations, they are able to get more more result in terms of more money, etc. So and also they are providing more user experience to the users. So like the only requirement here for this Microsoft Azure service is which is for the product recommendation is we need historical data because the underlying algorithm for this Azure service is like the SAS algorithm. So like for the so inside the SAS algorithm, the running algorithm is the collaborative filtering algorithm. So like as previously we have seen, we need the transactional data, which is the historical data, so that we can get the recommendations from that. So like from the product recommendation solution, we can get two types of recommendations. So the first one is the like item to item recommendation, and the second one is the personalized recommendation. So like the item to item recommendation is something like which is like more like content based recommendation, where you don't need the historical data and it will just take the characteristics and based on that it will give out the recommendation. But coming to the personalized recommendation, it is more like collaborative filtering, which uses some filtering algorithms like cosine similarity or other things where like based on that it will give out the recommendation, and for this you need the transactional data. So this is the main reason that for this service we need the like data. And also one more thing regarding this service is that like all the data should be present in a normal like different form that is mentioned. You have to like adjust all the variables and also all the columns based on that, so that you can use that data to train that in the Azure, using Azure services. So like speaking about the architecture of the system, which is based on the Microsoft Azure service, which is the product recommendation solution. So like first, when we actually create the product recommendation solution, like we so with that like a web application will be deployed with that, where it will have an like inbuilt API, where first of all API is an application programming interface where it can actually get the request and also to like transfer all the requests from one side to other side, which is from user to server or any other thing. So from the like app service web app, like it will actually first it will create a like web application, it will deploy it, it will create an API, and then like from that it will create an Azure storage service where it will use the blob storage, it will create tables, and it will also create queues. And and afterwards we have the job like web job instance, which is used for like training machine learning algorithms or any other algorithms here. So like when the data is transferred from the product recommendation solution, which is like all the data is stored in the transactional data, which is the historical data that I was speaking about. So the historical data, which is like stored in the blob stores, will be like going towards the web job instance where the algorithm is trained, and then it will be transferred again to the blob storage where from there you can use the algorithm. So for example, when we have the data, which is like when like all the training part is completed, and then when we want to like get the recommendation for some for ID, etc. So we give that like through an API when we provide that request to the Azure storage, and like this process will be pretty fast because like the training process is completed. It will just give out the recommendation from the Azure storage service. It will like provide like it will transfer from the storage to the training client or the user who is requesting that recommendation. And also we have the like model registry. So this is used for like providing the status whether the training is completed or not. So based on that, you can actually choose like try out different things until then until the training is completed. So this is all about the architectural part. So the resources I was speaking about, which is the recommendation systems in Azure, you can like check out the first link where you have each and everything related to this. So you can go there out like you can like understand the like in-depth architecture of the Microsoft Azure service. And like speaking about the FunkSVD algorithm before, like if you are really interested to check out the algorithm and also like how to create the user item matrix, which is really important. So you can check the last link, which is the GitHub repository that I actually provided you here. So you can go here, like play with this code, or use this in your own applications, which can be deployed afterwards. So, like speaking about the which is the Global AI Core Student Conference. For example, when you complete a Learn module, like for each and every Learn module, we will plant a tree, and like based on that, like when we complete more and more modules, it will be like forming a forest. So like this is a very great like initiative that is taken, and I think like based on that, we can also learn different things, and also we can actually kind of make a positive impact to the society because like planting trees is something which is very good for the environment. So this is all about it. So thank you everyone. So if you have any questions, you can post it here or in any different platforms. Otherwise, you can contact me via LinkedIn where I'm really active there. So thank you so much.
Thank you so much for the session, Kaushik. That was amazing. That was very informative as well. I learned a lot. So we have some questions.
Yep.
So what, in your opinion, is the best algorithm for recommendation system, in your opinion?
So, like in my opinion, like if you want to get personalized recommendations, then go with the collaborative filtering because it gives out the best recommendations because it is based on all the different users and like based on that, you like he or she can get personalized ones. But if you want the rank-based one, you can go with the weighted average, like or you have the rank-based recommendation system. So it totally depends on the use case, which is dependent on the different application.
Okay, that's great. One more question is that what are the best and most important metrics to tell that this recommendation system is very good or this is very bad?
So first of all, like for this evaluation, we can like what we can do is like the similar thing that we can do is in machine learning is that we can first train the model based on the data and then test it out so that we can understand how the recommendations are going, and based on that we can actually try out different algorithms. So you can use the machine learning, which is the entire pipeline for this same thing. So we can get based on that we can do the evaluation.
Okay, that's it from my side. If Stephen has any questions.
No, I think that was absolutely great. We did talk about different recommendation engine and covered a lot in just about 25 minutes. I think that was a great session, and thank you, Kaushik, for being a part of this event. I know it's Saturday, it's weekend, so we really appreciate your time, and we'd love to have you back when you're available. And yeah, thank you so much. And maybe it's time we move to the next session. All right.